Welcome to your video lecture. I know all that you wanted was to learn more about climate change, so that's what we're going to do today. Go to modules. It is day 5, more climate change. Doodle notes. You're going to need this or the editable copy to complete your notes. It's due tonight, but you are rocking and rolling already watching this lecture, so you're ready to go. Here we go. This one's going to be pretty short. Lots of Miss Bockover talking, less so about you typing down. But let's talk about climate change and what it does to the environment. Maybe less so animals and organisms, but just in a basic chemical makeup of our atmosphere. So, first we're going to start with looking at what we call the annealing curve. If you look, here's our date. Amount of carbon dioxide per parts per million in the atmosphere, and you can see based on this line it is increasing as we go through time in what we call an exponential pattern, meaning it makes a U shape. Good. Now what we know about exponential growth is there reaches a point where it cannot grow anymore, and we haven't reached that point yet. So our issue, or what scientists are alerting us to, is that as we learned in our greenhouse gas and greenhouse effect lectures, that the more carbon dioxide I have in the atmosphere, the warmer the atmosphere is. So if we are increasing in exponentially our amount of carbon dioxide in the atmosphere, we are increasing our average global temperatures as well. Again, the curve describes the change in the carbon dioxide concentration in the atmosphere. What does this graph tell us about carbon dioxide levels? If you were ever asked, hint, hint, on a test, maybe what this means, it tells us that the carbon dioxide is increasing at an alarming rate. What is carbon dioxide? Again, carbon dioxide, CO2, 1 carbon, 2 oxygen. We define it as a greenhouse gas because it's got that wobble, meaning that when infrared radiation hits this molecule, it will bounce back in all directions, which is awesome for heating the earth when it is nighttime and protecting us from the sun in the daytime, but it is not such a good thing right now because we're having more and more carbon dioxide. Means it's like we're putting more and more layers of coats on, making it warmer and warmer on the earth. So what does the increased presence mean for climate? It means that we are going to see a warmer and warmer climate, which we talked about yesterday, why that's an issue. We are increasing our scarcity of food, we're increasing the sea level, we are increasing melting of the ice, we are destroying species, we are creating more invasive species. None of it really sounds good. Again, this annealing curve shows an atmospheric trend of carbon dioxide. If you look really closely, microscopically, or with a little magnifying glass, there it is. If you look at a magnifying glass with this graph, you're going to see these little peaks and valleys. Predict maybe what those valleys are caused. What you would see is that those valleys are caused by a fluctuation in photosynthesis. So often our valleys are CO2 ratings when it is summertime, when the plants are doing their thing and vacuuming in that carbon dioxide, while our peaks are typically carbon dioxide levels taken in the wintertime when there are less photosynthetic active organisms, plants, phytoplankton, or algae. Good, and that's what causes those peaks and valleys. Very good. Moving on though, the next thing that happens in our climate change is an increased ocean acidity. Right now our ocean water's pH level is 8.7, which is not acidic yet, but it is getting closer and closer to 7 since. Oh, good. So our arrow actually goes right around here, which is not good. Ocean acidification is caused by CO2, the gas being absorbed into the seawater. The ocean has increased by 30% in acidity over time since we've been tracking it, and that's not good. That's all because of this increase of carbon dioxide concentration in the atmosphere. Good. Why might we care why the ocean acidification is an issue? Remember, we talked about how species are some of them very sensitive to changes in pH, like our coral. So as we are changing the pH or making it more acidic, we can cause some species to die out, not be able to live there anymore. And then we know when we lose species in a food web or food chain, it unbalances that food chain or food web, creating ecosystem chaos, which is never good. Predict how a change in the acidity would affect species and ecosystems in humans. Again, we just talked about that. So changing the acidity is going to make it harder for some organisms to live, meaning that they might die. And then if one animal or organism or group of organisms dies, we can upset the ecosystem. If an ecosystem dies, that can be very not good for humans. Even if you think in the most basic and superficial issue of economic gain, so often coral and like coral reefs and very beautiful natural places like that are big tourist destinations. If you don't have those, you can't have the tourists, and that means you decrease your economic value of the area. If you think a little bit more depthfully, the pH changes can cause fish species that we are eating to decrease, maybe because their food can't grow anymore, or because they can't grow anymore because it's too acidic. Or even same thing with our filter feeders like our oysters. So we might not be able to have seafood at one point if the ocean gets more acidic. All things to think about. And the very last effect of climate change is something we called an urban heat island. So this is an urban heat island. This is a phenomenon that we have defined as basically our urban or city lands are generally warmer than our rural areas. This happens because, if you can see based on my colors here, urban areas generally have less green stuff and have lots of black like pavement and buildings, and that causes the sun radiation to be absorbed into the earth instead of being reflected back out, something called the albedo effect, which we'll talk about another day. But that albedo effect is absorbing the sun's rays instead of shooting them back out like if they were white, and that generally will increase the temperature in an urban area as compared to more rural areas like what we live in. So again, urban areas are generally more warmer than the rural areas because they have darker surfaces like pavement that absorbs the heat energy, making the area warmer. We could have predicted that by breaking the word apart. Urban is city, heat, warm, island, piece of land. City, warm, piece of land, or a warm piece of land in the city. Generally, we'll find our highest temperatures in this city region than we will in the rural region, and that's basically what you need to know about urban heat islands. They happen, they're real, they're often an issue too. That's why cities are taking initiatives to do things like paint buildings white, decrease the amount of asphalt that they have in an area, the pavement, doing sustainable practices like, it's one of my favorite things to look at. What are they called? Eco parking lots. Let's see if this brings up what I'm talking about. Sure does. Okay. Eco parking lots. So the idea that instead of having an asphalt or parking lot that is completely paved like this, they've got these little Parker pavement things where grass can grow inside there. Now, not only is that good for not absorbing all the solar energy, it's also good for preventing runoff, so that the water bringing pollutants into the system, because instead of running off, it's going down into, because pavement is impermeable, remember, water can't pass through it. So this green stuff right here is really good because the water infiltrates into the groundwater, not running off into the river and bringing pollutants with it. Very good. All right, that is all I have to discuss with you today. Pretty short lecture. I'm going to link this video. I love this guy. I can't pronounce his name, but I love his videos. So you're going to watch this video as well. That's all I have for you. Enjoy your day on climate change. We'll talk about the albedo effect, and then we'll move into review and our tests. So this would be a good opportunity to start reviewing some of your material this weekend. Have a great day.